Hey kids, welcome to section 5.2, composition of functions. Today you're going to learn how to perform composition of functions and how to apply composition of functions. So first thing we need to talk about is what is composition of functions. And so if we have two functions f and g, and if the range of g is the domain of f, and the domain of f, and the domain of g is the range of f, then these are called composition of functions. So basically, if you have two functions f and g, if the domain of one is the same as the range of the other, and the range of one is the same as the domain of the other, then these two are called composition of functions. Now, there's this notation that looks like fog f circle g of x. That means f is composed with g, and by definition, f circle g of x is equal to f of g of x. So we're going to do a whole lot with compositions of functions and how you can put one function into another function and see what happens. So first, let's see if given two functions, if they are, if you can actually find the composition. So for each pair of functions, find f circle g and g circle f if they exist. So the first one we're going to find is f circle g. And if it exists, f circle g is the same as f of g of x, according to the definition on the previous page. So first I want to find f of g of, and you look at the g function, and the first one that I'm going to do is 4. So then I need to figure out what g of 4 is, and g of 4 is negative 3. And then I need to see what f of negative 3 is. So I go to the f function, I find x is negative 3, and the answer is 6. So f of g of 4 is 6. Then I move on to the second x, which is a 3. So I want to find f of g of 3. So I find what g of 3 is, which is negative 7. And then I find what f of negative 7 is. So go to f, go to negative 7. The answer is negative 8. Then I do the third order pair, f of g of 9. Leave the f alone, figure out what g of 9 is. That's 8. Look and find what f of 8 is. So I go to f, I look for x equals 8. There isn't one, so we're going to say does not exist. Then I'm going to do the last x, which is negative 4. So f of g of negative 4. Well, g of negative 4 is negative 4. And f of negative 4 does not exist. So when I put my composition of functions together, I'm going to start with a curly bracket, and then I'm going to put order pairs in. Whatever the x is that I put in, and whatever the y is that I got out. So 4 comma 6 is my first value, and 3 comma negative 8 is my second. Close with a curly bracket. So here is f circle g. Okay, then I need to find g circle f if it exists. So g circle f, by definition, is g of f of x. So first I'm going to do g of f of the first x, which is 7. So that's g of, well, f of 7 is negative 3. And then I go to the g function where x equals negative 3. I don't see one, so that value does not exist. Go on to the second, g of f of negative 10. F of negative 10 is equal to negative 3. G of negative 3 does not exist. Third value in f, so g of f of negative 7. That's equal to, well, f of negative 7 is equal to negative 8. Then I look for g of negative 8. G, no, negative 8, so this does not exist. And then our last value, g of f of negative 3. Well, f of negative 3 is 6. G of 6 does not exist. So therefore, this composition does not exist. So as you can see, some compositions will exist, some will not. And when you have one that does exist, not all of it has to exist in order for the composition to be found. All right, let's take a look at letter B. First, we're going to find f circle g. So by definition, that's f of g of x. So first I want to find f of g of -1 because that's the first x value in the g function. So g of -1 is 5, and f of 5 does not exist. Then you find f of g of the second x, which is 3. So that's f of -4, which equals -1. The third value, f of g of 6. G of 6 is equal to 4. F of 4 is equal to 11. And then finally, f of g of 10. G of 10 is equal to 8. And g of 8 does not exist. So my order pairs that I have are 3, -1, and 6, 11. There is my composition of f and g. Then I need to find g circle f. By definition, that's g of f of x. So first I want to find g of f of, and our first x value is -4. Well, f of -4 is -1, and g of -1 is 5. My next order pair, g of f of -2. F of -2 is 6. And g of 6 is 4. My next order pair, g of f of -1. Well, f of -1 is 10. G of 10 is 8. Last order pair, g of f of 4. F of 4 is 11. And g of 11 does not exist. So therefore, my composition is -4, 5, -2, 4, and -1, 8. Right, so that is how you find composition of functions when you're given order pairs. Now we can find composition of functions if we're given actual equations. So find f circle g of x and g circle f of x if they exist. State the domain and range for each composed function. Okay, so if I want to find f circle g of x, by definition, that's f of g of x. So what we're going to do is leave the f function alone, and we're going to replace g of x with what g of x equals, which is 3x minus 7. Then we're going to go to the f function, and we're going to substitute 3x minus 7 in for x. And so we're going to get 3x minus 7 plus 5. If we collect like terms, that's 3x minus 2. Then I need to find g circle f of x. By definition, that's g of f of x. So I'm going to leave the g alone, and I'm going to replace f of x with what f of x is, which is x plus 5. Then I'm going to go to my g function, and instead of writing x, I'm going to write x plus 5. So 3 times x plus 5 minus 7. So that's 3x plus 15 minus 7. That's 3x plus 8. Now it says to find the domain and range for each composed function. So the domain and range here, and the domain and range down here. Well, this composed function f circle g is a linear function. Linear functions, by definition, have a domain of all real numbers and a range of all real numbers. G circle F is also a linear function, which means it has a domain of all real numbers and a range of all real numbers. Okay, if we go to letter B, first we need to find F circle G of X. By definition, that's F of G of X. So I'm going to leave the F alone, replace G of X with what G of X is, which is X squared minus 10. Then I need to go to the F function, and instead of writing X, I'm going to write X squared minus 10 and keep the minus 4. That's going to give me X squared minus 14. Then I need to find G circle F of X. By definition, that's G of F of X. I'm going to leave the G alone and replace F of X with X minus 4. Then I need to go to the G function, and instead of writing X, I'm going to write X minus 4. So I have X minus 4 quantity squared minus 10. Well, I need to expand X minus 4 squared. And remember, X minus 4 squared is the same as X minus 4 times X minus 4. So if we double distribute that out, we get X squared minus 4X plus 16, and that minus 10 is still there. If I collect like terms, I get X squared minus 8X plus 6. Now I need to find domain and range. So for my first composition, X squared minus 14, this is a quadratic function. Quadratics have a domain of all real numbers. Now my range is a little bit different. Remember, X squared minus 14, if I graph it, is going to be a parabola that opens upward. Its y-intercept is negative 14, and that is also its vertex. So that means that I'm going from negative 14 and above. So I have a hard bracket to include negative 14 to infinity. The domain for G circle F is also a quadratic, so the domain is still everything. And if you take a look at your calculator, if you graph it, this is 4, negative 10 down here. And so that means that the minimum is at negative 10. So we're looking at negative 10 to positive infinity. Okay, well, let's take a look at what happens when we want to find the composition of functions, but of a value. So for instance, given f of x equals 3x minus 6 and g of x equals x cubed plus 1, find each value. So in letter A, I want to find f circle g of 5. So by definition, that's f of g of 5. So I'm going to leave the f alone, and I'm going to figure out what g of 5 is. I'm going to put it down here. G of 5 means go to the g function and substitute 5 in for x. So go to the g function and substitute 5 in for x. So 5 cubed plus 1. Well, that's 125 plus 1, so that's 126. That means g of 5 is 126. Now I need to figure out what f of 126 is. So I go to my f function and I replace my x with 126. So go to my f function and replace my x with 126. So 3 times 126 minus 6, that's 378 minus 6, that's 372. So f of 126 is 372. All right, letter B wants us to find G circle F of 5. Notice it's almost the same as part A, but the composition is backwards. By definition, this is G of F of 5. So that means leave the G alone and find F of 5. That means to go to the f function, and instead of writing x, I'm going to write a 5. So 3 times 5 minus 6. That's 15 minus 6. That's 9. So I need to now find g of 9. So g of 9 says to go to the g function, and instead of writing x, I'm going to write 9. So 9 cubed plus 1. That's 729 plus 1. That's 730. So G circle F of 5 is 730. That's really ugly. All right, let's see how to do composition of functions with a graph. So we're going to find G circle F of 1. By definition, that's G of F of 1. So leave the G function alone. Find F of 1. So that means find the F function, find x equals 1, and see where they touch. That's right here, which is right here, which is 3. Then I have to find g of 3. So that means to find the g function, find x equals 3, and see where they touch. That's right here. Figure out what the y is. That's right here. Negative 1, 2, 3, 4, negative 5. If we look at letter B, f circle g of negative 2, that's like doing f of g of negative 2. So leave the f alone. Find the g function, find negative 2, see where they touch, figure out the y, that's a 2. Then I need to find f of 2, so find the f function, find x equals 2, see where they touch, that's negative 1. All right, let's find composition of functions with the table. So here I've given you 5 x values. I've also given 3 functions, f, g, and h. And I've already substituted in all the x values into the 3 different functions for you and found the values. So in part A, I need to find h circle g of 2. So by definition, that's h of g of 2. So leave the h alone. I need to find g of 2. That means find the g column, find the 2 row, and see where they touch. That's 0. Then I need to find the h of 0. So find the h column, find the 0 row, and they cross at negative 2. Okay, let me get rid of these arrows. All right, the next one is g of h of 2. So that's like finding, or g circle h of 2. That's like finding g of h of 2. So leave the g alone and find h of 2. So here's h, here's 2. They cross at 5. Then I need to find g of 5. So I find the g column. I find the f row. Ooh, there isn't one. So guess what? This does not exist. All right, letter C, f circle h of 0. So that's like doing f of h of 0. Leave the f alone. Find h of 0. So here's h of x. Here's 0. They cross at negative 2. Then you need to find f of negative 2. So here's the f column. Here's the negative 2 row. They cross at negative 2. Last one, f circle g of negative 1. Well, that's the same as f of g of negative 1. Leave the f alone. Find g of negative 1. So find the g column. Find the negative 1 row. The answer is 1. Then I need to find f of 1. So find the f column. Find the 1 row. And my answer is 2. All right, so let's kick it up a notch. And instead of composing just 2 functions, why not compose 3? So now we have f of x equals x plus 2, g of x equals negative 4x plus 3, and h of x equals x squared minus 2x plus 1. So now I need to find f circle g circle h of 2. Well, by definition, that's f of g of h of 2. We're just adding another layer. So leave the f alone, leave the g alone, and we have to find h of 2. So that means go to the h function, and instead of writing x, we're going to write a 2. So 2 squared minus 2 times 2 plus 1. So that's 4 minus 4 plus 1, that's 1. So we're finding f of g of 1. Then I'm going to leave the f alone, and I'm going to find g of 1. So go to the g function. Instead of writing x, I'm going to write a 1. So negative 4 times 1 plus 3. That's negative 4 plus 3. That's negative 1. And then finally, I have to find f of negative 1. That means go to the f function, and instead of writing x, I'm going to write a negative 1. So that's negative 1 plus 2. That's 1. So my answer is 1. All right, last question. G circle H circle F of negative 1. So that's like doing G of H of F of negative 1. Well, I'm going to leave the G alone, I'm going to leave the H alone, and I'm going to find F of negative 1. So go to the F function and substitute in negative 1. So negative 1 plus 2, that's 1. Now I'm going to leave the G alone, and I'm going to find H of 1. So go to my H function and substitute 1 in. So 1 squared minus 2 times 1 plus 1. That's 1 minus 2 plus 1. That's 0. So now I'm going to find g of 0. So g of 0, go to the g function, substitute 0 in for x. That's 0 plus 3, that's 3. So my answer is 3. All right, kids, if you have any questions, please let me know. And as always, keep calm and keep trucking.